Eben Snowman voor ongelukkig, making a difference. We are now today looking at the second video in the trigonometry chapter, and today we'll be looking at double angles. So again, what we know from previous work is that sine of A plus B is equal to sine of A times cos B plus cos of A times sine of B. Now, again, if we rewrote this as sine of A plus A, and we look at what happened on the right-hand side, and we thought about it, I hope you'll realize that what we'll get is that sine of 2A will equal 2 sine A cos A. Now, I'm going to leave this here as being there while I work on the next one. But again, I want you to notice that there is only one formula. There's only one variant of outcome for this expansion. Okay, so sine of 2A is always 2 sine A cos A. If I look at cos of A plus B, which is equal to cos of A cos of B minus sine of A sine of B, and I now looked at what would happen if I looked at cos of A plus A, and I left you to play around with that. Okay. What I hope you would realize is one option I'd get here for cos of 2A is cos squared A minus sine squared A. Okay. And I'm going to be very careful to say that this is one of the variants. Okay. It's the main one, but it's one of them. Now, please be careful because this version here right now is very similar to something else that we already know. We know that sine squared plus cos squared equals 1, okay? And this is cos squared minus sine squared. So it's close, but it's not there. But it does lead us to think about what the other option is. So if sine squared A plus cos squared A equals 1, then it follows that sine squared A equals 1 minus cos squared A, or that cos squared A equals 1 minus sine squared A. Now, substituting those things in here, okay, leads me to saying that therefore this would equal, okay, so let's quickly do this better. I want to try and do this in a particular way. So this would equal cos squared A minus 1 minus cos squared A, which gives us our second variant, which is that cos of 2A equals 2 cos squared A minus 1. Alternatively, we would have got that this equals, coming off the top line, would be 1 minus sine squared A minus sine squared A, okay, which gives us the third variant, which is that cos of 2A equals 1 minus 2 sine squared A. Now, the fact that there are 3 variations for cos, but only 1 for sine, kind of says that if I ever am in trouble, deal with the sine option first because you know that there's only one variation. The choice for the cos variation, okay, since there are 3 of them, is based on context. If the rest of the sum contains sines and coses, change it to the first one. If the rest of the sum contains only coses, change it to the middle one. And if the rest of the sum contains only sines, change it to the bottom variation. Okay, so we are going to look at this in terms of how to use this in a sum. And I did have 2 the other day, 2 that we looked at in previous videos. We had, for example, something sine of 36. And they said to write down cos of 36 sorry, lies. Let's write down cos of 72 in terms of sine of 36. Well, we can see this as being cos of 2 times 36. So this would equal, now hold on. We've got the three variations. We've got variation 1 that contains cos squared minus sine squared. There's variation 2, which is 2 cos squared minus 1. And variation 3, which is 1 minus 2 sine squared. Now, again, just looking at the context of the sum, the context of the sum says write it in terms of sine squared. So if you write it in terms of sine squared, they are saying to me that this one is preferable. So I'm going to choose to write this one as being 1 minus 2 sine squared 36. And if you go back to the previous video, you'll have seen that, in fact, that is the answer that we got to that question. Okay. We saw also that in the previous case, there was a situation where we had an answer coming down to eventually sine x cos x plus cos x sine x, and we chose to do something different with it. What we could have done is seen that these two things were the same, even though the order of the factors is different. So this would be 2 sine x cos x, which would have been simply then sine of 2x. So let's look at one or two of the exam questions and see what happens. So we're given cos of 2 theta equals minus 5 over 6, and 2 theta is between that. So we can do a quick sketch of it. And we can say, cool, having drawn a sketch, it's between 180 and 270. So we know that the angle is there. There is 2 theta. And we know that is equal to minus 5 over 6. So we know that the hypotenuse is 6, the radius is minus 5. Sorry, other way around. The hypotenuse is 6, the x value is minus 5, which means that we could work out the height here, or the y component, the square root of 36 minus 25. So it will be the square root of 11. But because it's in the second quadrant, because it's in the third quadrant, it will have a negative value. So therefore, we know that sine of 2 theta in this case would be negative root 11 over 6. Okay, and we've done this without using a calculator. Now we're being asked to find sine squared of theta. Okay, and this again comes down to recognizing that cos of 2 theta has 3 variants. So we know that cos of 2 theta equals cos squared theta minus sine squared theta equals 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. Again, because they're asking us about sine squared of theta, they are screaming at us to use this right-hand side. Okay, so we're going to use the right-hand side. So we know that cos of 2 theta, which equals minus 5 over 6, is equal to 1 minus 2 sine squared theta. Let's take that one across. So we're going to get equals, therefore, taking the one across, minus 11 over 6 equals minus 2 sine squared theta. Okay, and if we divide by the minus 2, we're going to get, therefore, 11 over 3 equals sine squared theta. Okay, they haven't asked us to find sine theta, they haven't asked us to find theta, they specifically asked us to find sine squared of theta. And so if we are careful by reading the question, we know that this actually is the required answer. Okay, so again, be wary of these Pythagoras type questions that they now start asking for this topic. Okay. Okay. Simplify this down to a single trigonometric ratio. Okay. So 5.2.1. This combo of sine with cos makes me think that we've got the double angle ratio for sine. So sine 2x. But sine 2x is 2 sine x cos x. So 2 sine x cos x equals sine of 2x. So if I simply put a 2 in front of it, That'll be the same as saying that. So I'm going to have 2 sine 2x over, now hold on, 2 sine squared x minus 1 makes me think of 1 minus 2 sine squared x is cos of 2x. But this isn't that. This is a switch around of that, which means I've used a minus sign in front to change the signs, which means this is minus cos of 2x. And then what we notice is we've got sine over cos of the same ratio, 2x in this case. So that combo screams at me that I've got minus 2 tan 2x, and I now have a single trigonometric ratio because they've got only tan in my question. Okay, again, we've seen this before where questions are numbered in a way to try to assist you. See how this is numbered to say to you, see the connection between these. Okay, and if I do, I can see the one goes 4 sine x cos x, the other one goes 4 sine of 15 degrees cos of 15 degrees. So what I'm seeing here is therefore for 5.2.2 that therefore if I let x equal to 15 degrees, that what this thing would resolve to is minus 2 tan of 30 degrees. Okay, they are telling me to do this without a calculator, so I'm not resorting to any trickery. Okay, I will tell you at the end of the sum how I would use the calculator, even though it says do it without a calculator, but give me a second. Okay, tan of 30, whether you do it by the fan diagram or special triangles, whatever the case is, we know that tan of 30 is 1 over root 3. So we've got minus 2 times 1 over root 3. So this is minus 2 over root 3 or minus 2 root 3 over 3. Okay, now for me, when a question says to me, don't use a calculator, okay, what I like to do is I like to check my answer using the calculator because that tells me that my answer is correct and tells me that I can then move on with a large sense of a warm, fuzzy feeling of knowing that I've got the marks. So 4 times sine of 15 times cos of 15 divided by, well, let's actually do, okay, divided by brackets 2 times sine 15 times sine 15, sorry, let's close those brackets, sine 15 minus 1, and I'm getting an answer of minus 2 root 3 over 3, which is the same answer I've got here. So even though they say don't do it with the calculator, I would go and use this idea to check my work, and again, I'll check my work, because I'm an honest kid, afterwards. Okay? And the fact I've got this answer tells me I've got full marks, even though this question is only out of 2. Principle is what I'm looking at here, and knowing that therefore I've got full marks. Okay, moving on to the last one. This is a very different type of question to the previous ones. Okay, yeah, they've given you a diagram and they're trying to connecting it now with the trig rules that we learned back in grade 11. Okay, and they're making us play around a lot more with this question. Okay, so what we need to do here is, even though it's slightly unfamiliar, is just have a bit of faith in our techniques, okay, and look at the clues that they give us. Okay, now the first clue they give us is that they ask us for the area. Okay, now this is not a right angle triangle, which means we only have one clue, and that is that the area of a triangle is a half AB sine of C. Okay, not even, okay, so let's have a look at this one. Okay, so what we're going to get here is the area is going to equal a half times x times 20 minus 4x times sine of 60. We know that sine of 60 equals root 3 over 2. So what we got here now is a half of x times this will be what? Okay, so 10x minus 2x squared times root 3 over 2, which gives me 5 root 3. Sorry, let's just kill this. Okay, this is in brackets. So it's going to give me 5 root 3x minus root 3 x squared, which is what they've given me here, and therefore I'm happy. Okay, I thought this was a double angle question, and it seems like I've been conned into it, which is fine. Okay, so again, I've got what I would like to role model here to you is what to do if this question is slightly unfamiliar and turns out to work out slightly differently. Okay, so determine the value of x for which the area will be a maximum. Okay, now hold on. This is a lovely thinking question where they bring in all sorts of pieces of mathematics into bear. Okay, now for this thing to be a maximum, okay, we can either try to graph this thing or we can go back to our calculus. Now, remember, this is an end of the year exam. And if you're revising this trigonometry topic, in the first term when trigonometry is done at schools, okay, you might not know how this calculus thing fits in. But if you are doing this trigonometry thing as a revision for the exams and you've already done your calculus, you will know the keyword maximum. Okay, so we therefore know that if A equals that, then dA by dx will equal the derivative. So that's 5 root 3 minus 2 root 3x. And to find a maximum, you take the derivative and you make it equal to 0. Okay, so I can divide by the root 3's. And so what I'm going to get is that x equals 5 over 2 for my maximum. Okay, determine the value of x, which the area will be a maximum. I've done that. Okay, and then calculate the length of PR, which this thing is a maximum. Well, again, how do you find the length of a line in a non-right angle triangle? If you don't have the opposite pairing, okay, we do not have the opposite pairing at this point in time. So how do you find the length of the opposite side of a triangle? You would use the cos rule. Okay, so again, this is going to fall apart. 20 minus, so we know that, again, just quickly come in here. This is 5 over 2. And 20 minus 4 times 5 over 2 will be 20 minus thing, which will be 10. Okay, so we can go in here quite quickly now and pull out the cos rule. Therefore, PR squared equals 10 squared plus 5 over 2 squared minus 2 times 10 times 5 over 2 times sine times cos of 60. Tappity tap tap on a calculator. So 100 plus 25 divided by 4 plus the 2 and the 2 are going to cancel. Sorry, minus 50 times cos of 60 equals, I'm getting an answer of 325 over 4. And what is the square root of that? I get an answer of 9.01. Okay. And so we're done with that topic. Okay. So double angles are a part of our expansion of what we were doing previously with compound angles. You can get all the normal topics in there, equations, you can get identities, you can get graphs, you can get, as you saw, there was even a question there with a Pythagoras type question. So again, please don't be too surprised when this topic occurs embedded in a range of other topics. You can even get it in area and 2D and 3D area questions, okay? Which throws forward to our last video, which will be coming up, which is 3D trig, coming shortly. Thank you so much.